Good afternoon, everybody. Thank you for attending this session. My name is Sean Rickard. I'm the Senior Sales Engineer for Canada. I've got here Joe Como, who is you're the head honcho in charge over at UBC for technology, right?
Not UBC, we're at the Providence Healthcare.
Providence Healthcare. Well, still linked to UBC.
Yes. So yeah, I'm Joe Como. Go over a little agenda here. We've got, I've been here for, in research and computer systems for 30 years, mostly in storage or backup. We've gone through many storage arrays, Zyotech, NetApp, EMC, backup exec, TSM, many different things. And we'll talk about our SUSE enterprise storage, where we've come, because we started this process about 3 years ago. Hardware configuration, installation and testing what we did, some of the problems that happened and some of the problems that we caused, and our current VMware infrastructure and where we're going to be going with that. So who we are. Jim Hogg here, who started the lab 40 years ago. He's a Order of Canada recipient, and same with Bruce McManus. Jim is a lung researcher, Bruce is a heart researcher, and our current leader is Don Sin, who's a world-renowned COPD researcher.
I think it's important to mention to those that are not Canadian, the Honor of Canada, or the Order of Canada, is actually the highest award that you can be given in Canada, so to a civilian anyway. So it's kind of a big deal.
And we have 2 of them actually. So where we are, so we're on the west coast of Vancouver here, west coast of Canada, just above Seattle, about 2-hour drive. Just so you guys know where we're from. As we mentioned, I'm from Providence Healthcare. It's the oldest hospital in Vancouver. It was built in 1894. We're relatively young, Vancouver's compared to the rest of North America. And again, the center was started by Jim back in 1976. The new St. Paul's was just approved, just last month actually, and it's scheduled to be completed by 2016, and it will have an entire, this building here is going to be an entire research building, only for research, not for healthcare. For your knowledge, we are associated with UBC. Many of our researchers work dual side at UBC and or St. Paul's Hospital. Here we are here, that's the city of Vancouver. 10 kilometers away on this beautiful campus is UBC. If you ever get a chance to go there, it's quite amazing actually. So why SUSE enterprise storage? Well, a lot of our data is large. It used to be acquired fairly slow, so it wasn't that difficult to manage, but in the last 5 years it's ramped up. Projects have ramped up. Gene sequencing has gone crazy. We're getting sometime this summer, I'm told, 120 terabyte project. We don't have the capacity, or we didn't have the capacity before, and if we did, it was always a problem because you buy your array. Let me first explain research. You get research funding, and it usually lasts 3 to 5 years. So you have to decide at the beginning of your project what you're going to buy, and you don't get any more OpEx. That's it. So it's very difficult to meet these challenging needs of researchers. What ends up happening is you outgrow, or they don't specify the correct amount of storage required or resources required. And so we needed something different. So grab some water here. So we need something that's less expensive. The cost of arrays per amount of storage always stays the same. And then after you've purchased it, the maintenance doesn't go down. It typically goes up as they encourage you to move to a new array. And we needed the system to be expandable in a controlled fashion. Really what we wanted to do is move everything over to SES. We knew it couldn't be possible because it couldn't handle tier 1, but we wanted it to handle our Oracle and Microsoft MySQL databases. Non-high transaction, but we we needed it to handle this. And so we'll explain how we did it and how it's working and what we're going to be doing for the high transaction databases that we're going to be dealing with in the future. So we had to go through some configuration choices. If you go look at the SUSE website now, there's great documents on how to configure your cluster. Back when we were starting out, there wasn't any. SUSE and I think HP just jointly came out with one design for HP equipment. We're a Dell shop because the province of BC has a Dell agreement for supplying equipment. So, and they're great servers, and the team who we deal with at Dell are phenomenal. They help design and specify the equipment when we didn't have much knowledge around the specific equipment required. We presented it to SUSE, and SUSE said, yes, that looks very acceptable. So what we ended up doing was, at the time it was SES 3. We upgraded to SES 4 during our testing phase. We installed Intel P37 NVMEs, and we worked with Intel at that time with a project called Intel CAS, and it's a caching software. It wasn't available or didn't work with SUSE at that time. So we were beta testing with that. So our hardware at the time, 730 XDs, each server had a pair, I think, of 120 gig boot disks, 24 8 terabyte hard drives for the OSDs. We had two P37 2 terabyte NVMEs. And what we ended up doing is having 6 nodes, 3 monitors, 1 in mid-node, and a 40 gig network at the time was a very affordable piece of technology. 25 was very expensive at the time. So this is our network architecture, public and private. As I mentioned, we developed with the beta. We were the beta testers for Intel and SUSE, and you can get 2 versions of the Intel CAS driver. You can get the SUSE solid driver program, and you can get it free of charge right from SUSE, and it works really well. Or you can get the enterprise version from Intel. The enterprise version is slightly newer, has slightly more features, and if you're running Intel hardware, Intel NVMEs, this is a very minimal cost. If you're not running Intel NVMEs, it will work on certain NVMEs, but the cost is higher. I don't know the details. You can talk to Intel about that. So what we ended up trying to do was driving our cost down per gigabyte. Our maintenance went down a lot more. Expansion and scalability, we can now easily add more OSD nodes, of course, and scale it up or scale it out. Our performance compared to our array at the time went up. Capacity went up dramatically, and our latency, I'll show you, went down. So when we installed and did testing, basic testing, and this is what we got with our 40 gig network, and we did some iPerf tests, DD on both the disk and the NVMEs, showing the performance of those devices. We tuned the servers so that, excuse me, as much as we could with the BIOS and also the CPU settings, keeping the CPUs in C0 state so that they're always hot. We noticed that if we were testing some servers and running some loads on them, it could take up to 8 seconds for that last CPU to come up to speed to, I think ours are 2.8 gigahertz, so it could take 8 seconds for that last CPU, if there was 28 CPUs in the machine, to get up to speed. So again, some storage tests we did with Fio. We did this in most of our configurations. What we were did listed at the bottom is the exact file command we did. We tested this from some VMs outside of both SES and outside of our old array, so we could try to have a best of comparison. But it's going across, what was it, an 8 gig fiber channel versus a 40 gig SCSI, so it's really not a fair comparison. But here you can see the bandwidth between the two, quite a huge difference. IOPS, this is at the cluster. This was with the iCAS. I have a backup slide where we actually compare to somebody running some NVMe clusters only, and they're in and around that with just NVMe, and we're running that with NVMe's and iCAS fronting storage. The average latency to the cluster is that for that previous file load, and latency was at the 99.95 is what we picked. And these are both running from the same type of VM, which is I think a 4-core virtual machine with I think 4 gigs of RAM. What I'm showing here is our old array and SES4 with Intel cache. And you can see this is the tail latency, what we were trying to get that down. And why that was important for us is, again, the databases, so we can run regular data, not high transactional databases, but databases that store all the information about our images and stuff like that. And this is a comparison of SES4 with and without Intel CAS. And again, we were getting a much better performance with Intel CAS, and this is one of the things that we proved our pudding. I didn't mention this, but one of the things that when we went out to design our system, we looked at Comcast, a big cable company in the States. They have a whole bunch of Ceph clusters. I think they run 72 6-terabyte drives in each OSD node, and they have 16 or so OSD nodes per cluster. They have 5 or 6 clusters. The other company we looked at, and why we got onto Intel CAS, was Yahoo. Yahoo runs disk storage Ceph systems, but they front it with NVMe's and Intel cache. And the specific product they were using it for was, I think, Flickr. A lot of people are uploading tons or millions of images all the time, and they needed something to be able to sustain that write cache, and that's what they were using. So problems and some of the workarounds that we came up with. We had a weekly crash. Migration from version 4 to version 5 was an interesting problem that we're still having issues with. Operator error. Scrubbing is a big one, and I don't know if it gets touched very much, but it's a huge one. Placement groups. When we first started out, we thought we understood placement groups, but placement groups per pool versus placement groups overall versus creating a whole bunch of pools that you're not using that occupy space in your storage and therefore placement groups. Different issues. So ghosts in the machine, and this is when Sean and the Canadian team sort of became on board. We were experiencing outages, weekly outages, no given time point, 6 a.m. Monday morning to 9 o'clock Tuesday morning, different OSD servers would just start crashing. No idea why.
We spent weeks and weeks emailing back and forth trying to figure out where the cause of the crash was. We checked with the Dell stuff. We checked with Intel. We had our engineers, our backline engineers, looking at it, and we were just flabbergasted.
Nobody could come up with it.
Yep.
Did you lose any data by that?
No.
No, there's no data.
No data.
Yeah, this was not
It wasn't in production yet. It was still in the testing phase.
Yeah. But also, this was a sort of fault that would not affect the data that's already residing on the disk. This was just taking the cluster down and making it unusable. Yeah. Are you finished?
How many servers you had?
At that time, we had six OSDs.
And one server would crash at a time?
Yes.
Will it take the cluster down?
No, the cluster stayed up, but it was bogged down. All the nodes were bogged down by something we didn't know what at the time. And as soon as one went offline, of course, it wanted to start doing background work and moving data around, and which made it even worse.
Yeah. One of the other really random issues with this particular fault was that it wasn't the same server that would go down all the time. It would be a server, whether it be
Just one, or were multiple failures?
A couple times multiple.
Yeah.
A couple times multiple.
For the cause?
I'm going to. Yeah. So
We promise.
on SES4, using XFS, Intel CAS was treating all the disks like SSDs. So we had 24 SSDs, 8 terabyte SSDs per server. So XFS would kick off a trim or start it at 12:01 Monday morning. But it wouldn't actually fail then. It wouldn't fail till much later on until you had maybe 13 or 14 of the disks were doing trim. And it was cache causing it, yeah. Well, it wasn't cache. It was the fact that cache was fine. It was the fact that XFS was looking at the disks now as SSDs versus hard disks.
It was a combination of XFS and the cache. It's,
Yeah, and you know, at the time we were beta testing this with Intel. Intel didn't see a problem because they were testing versus we're running. So it took us 2 to 3 weeks to kind of figure it out, turn off XFS trimming, and everything was good.
yeah, and now that we are using Bluestore doesn't need trimming, so that issue is a non-issue anymore.
Exactly.
Which it makes it a whole lot easier.
So another problem we had, we were on Dell Force 10 switches, and great switches we're totally unfamiliar with them. We had Dell come in and configure them and set them up for us. But we had one of them, and we didn't know at the time that was faulty. It wouldn't give any logs. Dell engineers would come in and take a look at it. Everything was fine. All of a sudden, you could see it switch from one switch to the other. And then it would come back, and it would go back and forth, and it uses a VLT trunk.
And if I remember, that was actually around the same time that you were having that issue with the XFS, wasn't it?
It was.
So that also made the troubleshooting aspect a whole lot harder.
Yeah. And so what ended up happening was it was a faulty switch altogether, and it eventually just died, and Dell replaced it, and then everything's been great since. It's one of those really flaky things, and Dell couldn't diagnose the switch for whatever reason. There was nothing wrong as far as they were concerned.
It was a secret lemon.
Yeah. Upgrade. So upgrading from version 4 to version 5, we had lots of little interesting issues. We went from Filestore on version 4 to Filestore on version 5. Took about a week. We did each node, once a day. We had some salt issues. Later on, we went to Bluestore, and that's why we didn't do it at the same time, just to be careful. We also we're running encrypted. Most other people don't run encrypted, Ceph storage or SES, but we're running encrypted. Everything on the back end is encrypted. So we're taking a little bit of a performance hit there. So when we went to Bluestore, it was new to Salt, so SES engineers came in and helped configure the migration for us. 2 issues popped up. We didn't know how to configure the size of the wall and the DB, so everybody sort of came up with a logical, we think we have a 2 gig wall, a 40 gig or 44 gig DB, and we have a 2 gig partition for the encrypted keys. Now we've learned we could probably adjust that, and so when we go to SES 6, we'll probably readjust that. The other problem is it takes our servers 45 minutes to boot. The OSD servers takes 45 minutes to boot because of the encryption and because of UDEV. It doesn't find it right away. So it's very annoying. And that's because of Ceph disk, which is now being replaced with Ceph vol in the new servers.
So how would the encryption impact the startup time?
It's the mounting of the individual OSDs. For whatever reason, how Ceph, and I don't know the details, how Ceph disk mounts with UDEV the keys in the partitions and then mounts the OSDs. It doesn't go through an ordered index. It kind of randomly goes through the whole chain, and then it goes through the whole chain again. So it has to go through it 24 times until they're all mounted. So each time it takes like 2 minutes, right?
Something that can be optimized or
Well, it is optimized in the next version.
In the next version of SES,
Yeah.
they're going to change out Ceph disk for Ceph volume, which will allow you to have LVMs. So everything will go away.
Yeah.
Again, I just mentioned the slowdowns. The encryption is about a 10%, give or take, slowdown. Didn't really quantify it. Bluestore versus Filestore. We architected our OSD hosts with 256 gigs of RAM. So our servers probably had about 96 that it was being used. Now with Bluestore, we haven't had time to tailor Bluestore cache or look at that. We've got about 160 gigs not being used at all in the servers where it was used before, which was being used for cache, so we had better performance on Filestore being able to cache some of our reads. Of course, Spectre and Meltdown SUSE will talk to you about that. I actually don't remember what we've got configured. I think we have it turned off.
Well, I mean, you do have a privatized network, so the great thing is with the Spectre and Meltdown problems is that if your servers aren't web facing and you're going to have limited access to it, turning those off to get the performance back is not an issue. So.
Exactly. I already went through the boot times, and it'll be fixed with Ceph 6. Operator errors. Yeah, a few of those. When you're doing upgrades over the weekend and you're impatient, you have to wait for the cluster to finish. Even though health says it's okay, it can still work for 5 or 10 minutes doing some background work. Be patient. If you're impatient and you start redeploying an existing server too early, it will take your whole cluster down because you've got some placement groups that haven't been migrated over yet. Learned the hard way. iCAS, adding and removing RBDs with OpenATtic used to be a problem. OpenATtic 5.5 is wonderful. You can go in there and easily add them. You could do it with 5, no problem, but removing them was a little difficult. There's still a problem with large RBD, removing of RBDs. It's a cosmetic timeout issue. We have, I guess, 40, 50 terabyte probably on common, so when you go to delete an RBD, it appears to work, but then it gives you a cosmetic error. If you're patient and just wait, within 2 hours, the system will come back saying it's deleted properly and everything's hunky-dory. So, and I know they're working on that too.
Much better than SES6.
I bet it will be. It has been dramatic improvements every step of the way. It really has. Placement groups I mentioned. Scrubbing is a big issue. So what we did is we tuned scrubbing to run from 7 p.m. to 7 a.m. That's also when our backups run, so it affects backups. Here, this is a backup when you can see that the performance here, it kicks off. It's kind of interesting when it ends up happening, and then when scrubbing stops here, backup goes back up in performance. We took our deep scrub down to 28 days. I can't remember, is it 7 days or 14 days is the default? So we spread it out so you don't have as much at happening as once. And by doing that, it's picked up the performance right across our entire system, especially for backups, like I say, which run in the evening. Placement groups. When we were testing and stuff, we kind of glanced over the placement group, and so we created a whole bunch of pools, even though we weren't using them, but those pools had placement groups which affected the overall cluster, so we had to remove them and redistribute and increase the placement groups in the pools that mattered. Not a real big deal, but it does have a load on your system. So the other thing is Ceph Balancer, which it's a technical preview I just discovered, even though we started using it last month. It's in Ceph 5. It's a fantastic tool. It can use it. You can predict what you can show you can show what you are currently, and then it'll show you what your prediction is, and then what it goes through is go through and rebalances your disks for you automatically. You used to have to do it manually or rebalance by weight, by use. It became a little bit of a problem. This will do it for you, and you just kick off over the weekend. Kick off a few iterations to run, and it runs in our cluster about 4 or 5 hours each iteration, and it brings it down to a point where the disks here. I didn't grab a screenshot at the beginning, but our disks were close to a few of our disks were close to 80%, and most other ones were down around 50. So down at the end here, we got them all balanced a lot better by using the balancer. About 2 weeks ago, we're having some cooling work done on the roof. So we brought in a whole bunch of portable air chillers there. And I guess with the extra wind blowing, it decided to loosen up one of the cables or a pair of cables, and we lost a host. Yeah, Who would have thought that? So, but the interesting problem is we lost the host, but the host was still pingable over the Ceph network. So all the OSDs went down, everything went down, but it was an intermittent ping. We were getting 3 out of 4 responses of what's going on. So we went back there and checked and quickly turned off the server, opened it up, checked everything out so the card was mounted properly, reseated the Ethernet, put it back in, waited our 45-minute boot. Everything is up and running. Actually, if you think about it, even if you had a great service model by Dell or anybody else, usually it's the shortest time is a 4-hour window, and we were back up and running in about 4 hours. So, here I'm going to show a little bit about recovery of the system at that time during the NIC failure. The user is still running here, and this is the recovery, the back end of the Ceph cluster. What's interesting is over here this is our dirty cache. I didn't really mention this earlier, but when we were running the first version or first iterations of Intel CAS, our cards were full. They weren't writing the back-end data to the storage right away. They were storing it in the Intel cache and writing it later on. The problem with that is they were always full. They were waiting till they're full and then writing it out. They're still full. They still retain the write back and their read caches, but they're writing it immediately. So in a normal operation, this is 0. But when they do a read or a write to cache, it immediately still goes there. It still sees that it's there, pulls it from there. That has already been committed to disk already. So we only see this when we have a recovery failure here or when we're doing a placement group change. So now we'll talk a little bit about our VMware config. So we have about 150 VMs, quite a few small ones, some large ones. We're occupying about 120 terabytes currently. We're still moving them on as we're coming up with data moving plans. Everything is on SES. Backup is also on SES. And we have a remote backup about 350 kilometers away, which is in the interior of British Columbia outside the earthquake zone. And that's about 200 terabytes. And that's a data domain, a Dell data domain. So our hosts, VMware, we have 3 of them, 256 gigs, 24 cores, SSD for boot, again 40 gig NIC. We have a 1.6 terabyte NVMe in the server for caching, and later on I'll explain a little bit what we're doing there. Our network is again 40 gig. Our internet is only a gig, so outside of our hospital for research. So the software, we're running the latest vCenter, running virtual cache for in-caching in the VMware servers. Veeam is the latest Veeam and latest update for Veeam. And our local backup repository, we're now running Windows 2019 with ReFS. We were trying it with Windows 2016, and if you go look at, there's a whole bunch of forums on Veeam about problems with Veeam and ReFS and corruption, and we were experiencing that for the last year. We thought it was fixed. Everybody said it was fixed, and it appeared to be fixed, but it only seemed to work fine for up to about 5 or 6 terabyte VMs. Once we have 10 or 15 terabyte VMs, it would just not work. Nothing would just sort of halt. It wouldn't crash. It would just sort of stop working. And again, we worked with Microsoft. It took an additional 6 or 8 weeks, and they got us some field test patches. And they gave it to us for 2019, not 2016, even though that's what we're running. So we downloaded 2019, put the patches in there, and it works wonderfully. I'm not too sure if they've shipped the patches or not in 2019. I think they have. So this is the virtual cache that we're running in the host servers. And what we get here is, even with iCAS, and depending on what you're doing, when it has to go out to write, if the system is busy or whatever, you'll get a latency on the network or the latency on the VM itself. But the cache here is what we're writing to here. And so you write again to the local cache in the host VM, and then it offloads it to Ceph. And again, that helps with our databases. So our iSCSI config, we have 2 portals right now. We have 5 RBD images, all in the range of 30 to 70 terabytes. OpenATtic is great. It's just a couple clicks and you've got it configured. It goes through and configures the iSCSI gateways, and then VMware automatically sees it and updates everything. You don't even have to do anything more than that. Tuning. SUSE has both of these documents. We adhere to both of them. In addition, we've like I've mentioned earlier, we take our CPU states down to 0. We're running at no power saving at all. We're running at every CPU at max for our entire Ceph cluster. And we're trying to figure out round robin for the iSCSI settings on the gateways in VMware. Depending on who you talk to, the default is 1,000 for round robin. SUSE has a couple documents, I think that one that mentions 100. VMware says you should set it to 1. I'm not too sure where it should be, so we're waiting to figure that out. So our backup repository, as I mentioned, is ReFS file system. It allows us to maintain 4 weeks of backups locally, only occupying about a week's worth of actual space, backup space. And so here I try to illustrate, this is how much space is free on the RBD before the backup, and that's how big the VM is. And then during backup, you can see it starting to write here, and it's still the same there. And down here, you can see it's used just marginally more space, but yet we have 2, I think what are they, just under a terabyte each. And it allows us to have these here locally. And so when people want to do a restore or something, this allows it really quick. Otherwise, we have to go over the 1 gig line, 350 kilometers away. We can pull it back because there we have it backed up as well, but it takes a lot longer. So the problem with VMware and all Windows and even Linux applications running in VMware is most of them are single-threaded and they don't get very much performance. The Ceph cluster, if you have a multi-threaded application, it can really take advantage of it. Well, you can kind of get Veeam to be that way because you have a whole bunch of Veeam proxies and you get it to do a whole bunch of backup loads. And this is us reading from our Ceph cluster at 575 megs a second. And we're going out that pipe a much slower speed because it's doing dedupe and everything else along the way. But you can get it to respond pretty good. Well, it's just illustrating that fact. And then this is just the same information on a different view. This is the cluster itself. These are the 2 iSCSI gateways here working. And again, you can see this is our cache hit here as we're actually starting to use cache during the backup window. This is just OpenATTIC's view. Everything's off by a few minutes, but again, here's OpenATTIC's view of how much data is being moved. So our futures. I mentioned the cache and the server, and basically hyper-converged vSAN or storage spaces direct are probably the things to think about. We'll just add that into our VMware servers ourselves. By doing that, we'll put in some NVMEs in the servers. Those high latency database requirements will run on those systems, meeting our smaller environment, saving hardware costs by buying either a storage array to meet just those specific requirements or separate servers. And then because it's on our VM host where Veeam and everything else is in our Ceph cluster is attached, we can easily back up or do different things, snapshotting from one system to another. That's what our plans. We're also looking at, for some other projects, AMD EPYC servers with some some NVMEs and Optanes because we're getting in, the start of the summer, we're going to get in a small cluster, probably about 2,000 cores for genetic analysis. And we've already started ordering some NVIDIA graphics CPUs for analysis, well, as I mentioned, all the images that we store. And what we'll be doing is, as other people are starting to do, is using Ceph for connecting to the cluster. We're hoping that it will meet our requirements. We're going to add some more storage nodes. I'm not too sure how many we're going to add, but probably another 7 identical nodes. We're now running a combination of Dell 730XDs and Dell 740XDs, and we're just going to be adding more of the same. We're also running Intel Optane P3700s were the originals, and P4800s is what we're using now. You have to be careful on the requirements for the NVMEs. I think I said Optanes, but you want those NVMEs to have long drive lives, lots of life on those drives. So we're also thinking about replacing our iSCSI portals because I can't remember off the top of my head. I think they might be some slower processors, 2.7 gigahertz, and you can easily get, for very little dollars, you can get 4.8 Xeons for $3,000 or $4,000. That'll probably suit our needs a little more. So we have a large helper in our office, and initially when we started this project, Cameron was the tech who helped us sort of figure everything out. Scott Warner and Craig Little came in and helped us. A real big help on SUSE's tech support is Boyd. We come to him a lot of times with questions he's never even heard of before, so he's great help there. And then just as we were going online, Sean, Matt, and Max are the Canadian SUSE team, and they came on just as we were experiencing our trim issue. So we put them to work right away, and they've been a great help too. So I have some backup slides here. I don't know if you guys want to go through them. I have some more slides because I didn't know how much time I'd have. We can go through them a little bit if you'd like. Do you have any questions about what I presented so far?
So your Ceph cluster, you've got your iSCSI interface. Are you consuming the major part of your storage via the iSCSI interface, or are you using?
Yes. That was our first to try to get off our old array. Our old array was a Dell EMC, 200 terabytes, give or take. And so we wanted to get all that migrated and moved, and another problem I didn't mention, I should probably mention, is in creating your VMs, in order to, this is our problem because of our WAN length, you create VMs with smaller disks. So you create a VM, instead of creating a 10 terabyte VM with one 10 terabyte disk, you create it with 5 2 terabyte disks, and you splice them together in the VM. What that does is allows the VM proxies to go in and read each 2 terabyte disk individually, allows it to get better bandwidth push, and that's what I was illustrating there about getting more bandwidth. So again, we started the migration with 10 terabyte VMs, one disk. It's like, this isn't going to work, so we had to rejig everything and come up with that methodology.
So, of course, when you're looking at VMware accessing its storage, it's basically single-threaded. You're
Correct.
not getting the high performance. Have you looked at creating multiple data stores and using a data store per host and additional data stores for data volumes to provide some kind of parallelism?
We're trying to simplify everything. We are getting a 90% hit probably on iSCSI versus the RBD or Rados, what you could performance-wise get if you went directly. We have a limited team. We have 2.5 people. So we have to have a solution that moves the data over, keeps it running for mostly Windows applications. There's a few Linux applications, but mostly Windows medical applications. A lot of these are, when they're delivered, even if they're delivered now, are delivered with Windows XP. That's just how they do it. So we have to keep them going, keep all the users happy. And then, as I mentioned, we have this HPC grant for this HPC cluster coming, and we have to get moving on some other projects. So we've been working with Dell and Intel on on getting some optames running for some specialized servers that we want to, again, for affordable reasons, they're a little different than a normal HPC cluster. And we want the data storage to be on our Ceph cluster. That's why we're going to grow the cluster that way. The other thing is we're going to have to tackle how we're going to back up that data that we're going to put in Ceph FS with our small pipe, and what we're going to do and how we're going to offload it. The idea I'd like would be to have another Ceph system somewhere else and just clone it, to be honest with you. Yeah, well, just let it replicate. I mean, it would.
1 gigabit length?
I don't know.
That would take a while.
It'll take a while, right?
I have a couple of things.
Yeah.
One is I have a question on vSphere version you used. Can you say you had the problem with the performance with multi-queuing? What version of vSphere do you have?
We're running 6.7 update 1, I think it is. The latest.
6.7 and you still have multi-queuing problem. And was it through iCAS going to the NVMe or?
Well, we're having a problem right now, and we've ruled out our network, and we ruled out iCAS, and we ruled out, what else did we rule? We ruled out, because another vendor, another party set up on some Supermicros, a SLES basic config. They put up three servers with the OSD host, a monitor, and iSCSI gateway running on the 3 boxes, and they see the same problem because they're another hospital. They have they had a VMware infrastructure, and they had 100 VMs that they could just pound with it quickly.
And the reason I was trying to get that information was because vSphere had an issue with multi-queuing to NVMe.
Oh, really?
And
Uh-huh.
it was fixed
Ah.
in the later versions of VMware.
Okay.
And so that's why I was, because if you put NVMe, and because you were using iCAS, so you were making NVMe the target for your vSphere, so that probably would have been the reason. And so it was no issue.
No, with the other site proved that it was not. It was hard for us to prove that when we're in production, right? So we could uninstall the iCAS and uninstall the drivers. And we could uninstall Virtual Cache as well, but it became a problem for us because we are in production.
If you have a quick second, can I ask?
Sure.
One of the slides you mentioned, you had your target backup was a data domain.
Yeah, that's the offsite, the 350. Yeah.
So your Ceph clusters data, you were backing up to the data domain
Yeah.
as a data protection
Yeah.
over what?
Yeah, it's what do you call? Yeah, it's NFS. Yep. Yeah, it's using. Well, we're using Veeam to talk to the data domain directly over it. I think it's NFS. On the data domain side, there's a. I can't remember off the top of my head. There's a selection for Veeam.
The S3 connector domain, but
Yeah.
you use NFS. That's something I'd like to understand a little bit more. Maybe offline I'll connect with you.
Yeah. Yeah. It's just a standard.
Research topic to understand that.
Sure. Yeah, it's just a standard. It was the simplest way to get our critical data offsite in case, because we're in the earthquake zone. We're in an old brick building built in 1910, I think.
DDV by any chance? Did you use DDV, Data Domain Virtual Edition?
No, we didn't.
You had the appliance.
And we don't have the appliance. The province of British Columbia has purchased, or all the education sites has purchased a data domain in Kamloops in a province government data center, and we and a few other people were guinea pigs to first use it. UBC campus, I think this summer is going to start using it for the entire campus, because right now they only have marginal DR depending on different departments and what they're doing, but the idea is everybody to use the data domain. And they may or not be using Veeam. They may be using a another data domain or appliance.
DDV, because you got to use DDV.
Yeah.
You weren't using appliance on your side.
Yeah.
That's how you
Yeah.
push it out.
Yeah. So I'll go over some extra slides I threw in here. So this is Observium. It's a great tool to look at your networks. So this is just looking at one of our iSCSI gateways, and that's the traffic of one of them in one 24-hour period. So we move about 10 terabytes of data back and forth in one day. This is some great stuff. Again, I'm not a Linux administrator. I'm a storage guy for 30 years. Boyd gave us this little beautiful little script to tell us what our 20 worst disks were, and we use it all the time because we need to make sure that where we're at. As wonderful as Ceph is, you still have to go through the purchase order state, and it can take us 6 weeks to get a request for a PO, get it approved, get it out to getting a PO. It takes two weeks for a PO. The vendor then takes 2 weeks to deliver it. So it can take 6 or 8 weeks. So we need to be aware of where we're at in storage and where we're going to be going.
Just a question about the queries. Would this be something that would have been useful to have in OpenATIC?
Yeah, it'd be wonderful. Just a button? Yeah. Good thought. Yeah. I mean, you could set it for however many disks you want, I guess, and then just tell you how full they are. So again, this is when I was, what was I doing? I can't remember. Oh, balancer. I got it in the title. Sorry. Whoops, hit the wrong button. I think this is a bug because there's no way the client-side network was ever doing that. I think it was multiplying whatever the back end was doing, and that is consistent here. You can see it doing a 17 gig per second recovery, and it does that, and it slows down. Yes?
Do you make any changes to the default configuration of how much I/O Ceph spends on recovery versus serving client loads?
We do, yeah. We do this on the evenings, on the weekends.
Okay.
In order to get it to go through faster, while we're doing this, we turn off Veeam because you don't want the Veeam being your front end trying to do 500 megs a second while you're doing a gig or so on the back end. Right? They won't work together. So we disable backup while we're doing it. We don't do this all the time. We did it for a while, one weekend all the time. Once we got everything balanced, everything is pretty good now.
Okay, so you basically disable the workload in order to have more IOPS for the recovery.
Correct.
So, but the Ceph provides settings that allow you to change the ratio between how much activity it spends on doing recovery versus
Correct.
serving client. So you're not making changes to the Ceph settings per se.
No, we're leaving it as default at the beginning of the run. As it gets, I'll say it takes 5 or 6 hours to change the placement groups. As it gets towards the end of the run, we increase the workload that Ceph can do in the back end to redistribute just to get it to finish faster. And then after it's finished, then we take it back to the default. And the only reason we were doing this is to get it, try to go through 4 or 5 iterations in one weekend. So we turn the major workload off during the weekend.
I think this throttling is also dependent on the CFQ scheduler
Yes.
being used, which isn't always the case.
Good point. So I mentioned CPU settings. I can't even read my own slide. Yeah, so this here I think is our iSCSI gateway. And everything is set to the fastest that the CPUs can run. So we just created a system D service and put it in there after already doing the adding the tuned in from SUSE. We just tweaked it a little bit further because the tune doesn't get you this. It still gets you some wait states. And here I'm just illustrating the CPUs with and without. Here we have them all running at almost 100%, and here they're running with some wait states, it's really noticeable when Veeam kicks off. You can see Veeam kick off, and it'll take a few seconds for all the CPUs to start coming online.
In the BIOS,
Yes.
we have a thing called Dell processor acceleration technology. Were you able to make use of that?
we have them set to performance. In the 730s, it was pretty obvious. The 740s, we had a hard time trying to find some of the settings. We eventually found them because in the 740s, the settings were unintuitive to us. The 730s, it was very easy to find. 740s, we couldn't get in and let the operating system control the machine. The server wanted to control via the BIOS. So it took us a few hours to dig around and find them. Once we did that, we can get in here and control. There's a few other things we can tweak in the BIOS. I'm hoping that your document will be available, and I'll go in there and look at that. Yeah, that's what I was going to head to. Again, changing our scrub setting. This is our scrub settings here. And it took me probably 2 or 3 months to get to a place where I was happy. Because no matter what I did, scrubbing would affect.
You're still a 6-node cluster?
7 node right now. Yeah, and we're going to probably add another 3 or 4 at least this summer. We're running 24 8 terabytes in each, so it's 1.2 petabytes raw, give or take. I can't remember the exact number.
Did you virtualize your MTP?
It is. We're probably going to go back to hardware. We don't have it virtualized on the Ceph cluster. It's on another system. But yeah, we're going to have 2 hardware NTP servers, just independent, not virtualized, because they do wander ever so slightly when they're virtualized. That's another thing I should have put in the deck. When you use Deep Sea and everything else, again, thanks to Boyd, I didn't know about this Deep Sea monitor. It's a great tool. It tells you what's going on with Deep Sea when it's going through and running stuff. You run Deep Sea in one session and you monitor it in another, and it gives you lots of information about what's going on when you're issuing the SALT commands. And a 3rd or 4th window you keep track of when your OSDs, because it takes 3 or 4 OSDs down while it makes changes and restarts them. So you can keep track of all this in a couple windows and make sure everything's going along fine, because it can take, depending on what you're doing, an hour, 2 hours for this whole process to go through when you're making changes. And again, just another window watching your Ceph, making sure everything's fine here and what it's doing here on.
A question about the upgrade process, but you didn't have to take any workloads down during the upgrade.
Well, we didn't take anything down.
Right.
Everything stayed up. We took 1 node down at a time, redeployed it, destroyed it from the cluster, re-added it in, reconfigured it, and let everything rebalance. That's why it took a week, because each day it rebalanced.
So you drained the data from the node before? Okay.
Yeah, exactly.
Is the 40 gig still sufficient?
Oh, 40 gig is more than sufficient for this. I wouldn't go with 40 gig. I mean, at the time we didn't know better. 25 gig is better than 40, because 40 is really just a bonded 10, four bonds of 10. So you're getting the equivalent of latency of a 10 gig network versus latency of a 25 gig network. And but it was a very affordable solution at the time, because they were, I guess, putting it on sale for us. And we got really good deals on the cards too and everything else. So it's still a good product. It's used heavily, the 40 gig networks are used heavily in the film industry, if you're interested. That's where we learned about them.
All of your workload has been randomized.
It's all random, yeah. We were looking for IOPS to make sure that our low threshold databases would work. That's what we wanted to move. And then, as I mentioned, we're going to be putting some NVMEs into the VM host and putting up vSAN or most likely vSAN. And that way we can get those high requirements for those databases that we do have for transactional purposes on the same equipment, reducing our footprint, reducing our management, and a few other things. So when we were increasing our placement groups for some of the pools, I hadn't seen our on iCAS, it get as high as this after, Intel made some of the changes. So when you're changing your placement groups, you can see that iCAS was doing a lot of work caching all the changes. And the nice thing about that is the user's never seen a tick because of the caching and everything else. They didn't even know this was happening. And we did this. We started doing it on the weekend, but it got tiring always working on the weekend and coming to work, so we did it during the week too. So this is interesting because last year OpenStack was in Vancouver, so we went to that, and they had a special Ceph conference called Mount Point, where a lot of the Ceph people were out here. And so we went to that, and we met a few other people running clusters, Ceph clusters, and they were all non-SUSE clusters. And so we started talking, so we got some comparisons out against what we were doing versus what they were doing. And they did some tests, and we copied their tests. I don't know exactly what NVMEs are, but I'm pretty sure they're in the same class as what we are. But our price per gigabyte for what we're doing and what we're getting, and this number here is was 20,000 IOPS. If you look in my slide deck earlier, it was 30,000, and that's because of iCAS. iCAS gives us about an extra 10,000 IOPS over our cluster, which puts us in line with just running an NVMe only type cluster. So everything's good for small, reasonably sized writes. If you want to stream, like a stream of data, you're going to fill the cache up, obviously. You won't be able to fill that. But for most everything we do, it's perfect workload for us. And by adding more and more nodes, it'll just get bigger and better and faster. So I think that was my last backup slide. No.
No, you went over that one already.
Oh, did I? Okay. Yeah, that was everything then. So any other questions? Or hope this was helpful, because this is what we're living in real world. And if you go to a Ceph cluster, you're going to experience some of these issues too, or have different ones probably. Okay?
Thank you all very much.
Thank you.